Hello there, friends and neighbors. I want to show you now how to do an example of linear regression with prediction. So here's the situation. There's an iPod Touch, and it's been out for 2 years now, and a lot of data has been collected. Here's the relevant relationship. There's a functional relationship between price of an iPod Touch, P, and the weekly demand, S. Below is a table of the data that have been collected. Now, we could very reasonably copy these data. I'm just selecting it and move it over to, let's say, Excel, a spreadsheet, and that would let us, let's say, make a scatter plot. So insert scatter, and there, now it's got a scatter plot. Okay. The linear model that best fits the data using regression has a slope of negative 0.3257. Now, in an actual regression equation, you would not retain this many decimal places, but for purposes of this exercise and just because it's kind of fun, we're going to do so. That's the slope. So I'm going to come over to Excel where I want to do some computations. I'm going to move the graph out of the way a little bit and put in the slope, M. And I'll label it, and then here's where I'll just paste that result. That's the slope. It's got an intercept of 258.14 to I'm going to copy that. Come over here, and B is what I'll call that, and I'll paste it there. Now, if I wanted to get this from Excel, I can do that really easily. Just click on one of the dots, right-click, where it says Add Trend Line. Click on it, and it gives me many options for trend lines. This particular one is a linear. The only other thing we're learning in this class would be polynomial if we wanted to fit a quadratic model to it. But let's stick to a linear, and I can say display the equation on the chart. I can also display the r-squared value. And then maybe I don't want it to be a blue dash line. Maybe I want it to be a solid line. So I can change that property as well. Click out of here and come to the line. Right-click on it, format trend line, and I've got some options over here, like I can color it, and I can get rid of the dash, make it a solid line. But all of that is sort of extraneous, just sort of extra fun, not required. But you can see that the regression equation that you have in the output is, in fact, the correct regression equation. I have given you all the information in the question itself. Enter the model below as a function, and what I want you to do is enter the nearest 0.01 for the slope and the constant to the nearest whole number. So that means we're going to express this as negative 0.33 times p, the variable, plus 258. And that's it. You can check your syntax, and it looks like the syntax is okay. Now, the correlation, R, is negative 0.981. What's the R-squared value? Well, it's very simple to compute the coefficient of determination. I take my R, and I square it. Equals that number to the power of 2. And it's 0.96, which is above 0.95. Now, 0.95 is a very extreme threshold to use. It's not like something has to be 95% to be good. But what this means is 95% or more than 95% of the variation in the outcome variable, which is weekly demand, can be explained by knowing the input variable, which is price. Okay? And the higher the price, the lower the demand. That is because the correlation is negative. The square correlation tells me that over 95% of the variance is explained. So that's that. Now, for the rest of this, we use the full kit and caboodle, the parameters that I gave to you up here in full decimal unrounded glory. What does the model predict will be the weekly demand if the price of an iPod is $177? We want to round to the nearest dollar. Oh, let's show the answers we've seen so far. So, to the nearest dollar. What I'm going to do now is, let me get this out of the way. I'm going to have a section here for X, and I'll have for Y. So y, let's plug in my x. X is 177. And y is equal to m times x plus b. That's mx plus b. And rounding to the nearest 100, this is 200.491. What are these in thousands? Let's see here. Oh, yeah, in thousands. So I'm actually going to multiply this times 1,000 and then round it off to the nearest whole number, which it already is. Oh, no, not to the nearest whole number. They said to the nearest 100. Yeah, nearest 100. So 200,500. 200,500. And that's the answer. And last part of the question, according to the model, what should the price be set at in order to have a weekly demand of 232,100 iPod Touches? Well, that means that I have y set equal to that value. Y equals 232,100, 232.1. Because recall, we divided by 1,000 for this exercise. And now I have the y, and I just have to solve for x. Well, if y equals mx plus b, then it follows that y minus b, let's rewrite this, let's change the sign of it, equals y. It follows that I could subtract b from both sides using the magic of algebra, and then divide both sides by m. And that's how I'm going to do that. Divided by m. And that's how we get it. So let's go ahead and do that. Equals, my y value was given to be, what was it again? 232.1, which is right here. Y minus the slope, 258, and divide that result by, the intercept, and then divide that result by the slope. Hit enter, and I'm going to get x. So when y equals 232.1, x equals 79.9561, and we want that to be to the nearest dollar. So that should be $80. 80. So submit them, and hooray! They're all green. They're all correct. All right.